Several students have been asking me what's going to be on the test. Hopefully this video will answer that question. The first and primary topic of the test is second-order circuits. We've been discussing really nothing other than second-order circuits for the duration of this class, so I don't think this should be much of a surprise, but let's go through some subtopics that you would be expected to know. First, you should be able to find the characteristic equation. And this, I maybe would think that you would be able to find that not just of series or parallel circuits, but of more complicated circuits, like the Review 3 video that I posted today. If you are able to sit down and write down the differential equations and then get to a second-order differential equation, then you can get to that characteristic equation just by substituting in the idea that we have something like a e to the st, something like that. And then since that's never zero, the rest of it will be equal to zero, and that'll be your answer. Once we know about characteristic equations, you should be able to find the roots, and so we often think about that in terms of alpha and omega. And for here, with alpha and omega, you will probably be thinking about having those equations for series and parallel circuits just sitting in your notes ready for use. I probably won't ask you to find the alpha and omega for a more challenging circuit on the test. I'll just restrict that to series and parallel. Now, in addition to those topics, we should have the general forms of the solution. So we're talking underdamped, overdamped, critically damped, etc. And then in addition to those general forms, you should be able to find the coefficients, right? So you should be prepared to find coefficients during the test to solve a 2x2 set of equations. In addition to being able to solve for coefficients, you should know the terms natural and step responses, where natural responses refer to when you remove sources from a circuit and suddenly it just devolves down to zero of its own volition, so to speak. And step responses are the response to attaching a source to the circuit, and it may or may not have stored energy when you attach that, at least in this class. Some people say that a step response has to have no stored energy. We're going to use it in this class to be anything when you attach a source, and how does it respond to that sudden attachment. It can have stored energy or not. We're also going to talk about initial and final conditions for circuits. So you should be able to solve for the initial conditions, knowing circuit theory 1 sorts of topics like, capacitors don't change voltage instantaneously and inductors don't change current instantaneously. And so you could look at a circuit and decide what was and wasn't conserved at time 0. It would behoove you also to have a little bit of circuit theory 1 in your back pocket. And by a little bit, I mean really most of it, but certainly KVLs and KCLs are important things to have around. And I would encourage you to have on your card or otherwise the standard source transformations from Thevenin to Norton and vice versa. The last thing you should have at this point is you should have the differential relationships for L and C. And you should have those in your head. You shouldn't have to write them down, but you can always write them down if you're not sure or if you're prone to making mistakes during the test period. I think that if you have these things, you should be pretty well prepared to take on this exam and do well on it.